All right, so with me, I have my good friend Stefan from Sentry. So, Stefan, how are you? And please introduce yourself.
Hello, world, and hello, Sam. It's so good to see you again. I'm Stefan. I work at Sentry. I'm in our Vienna office, and we build error monitoring tools. And with a lot of power that we built up over the last month and years, we are also investing into AI to go into error prevention.
Right, nice. Now, again, as a .NET developer, you kind of already said it, but we should not be any strangers to Sentry. We love what Sentry does, but tell us a little broadly, like what all do you folks do?
So we Sentry as a error monitoring and performance monitoring platform serves to observe and instrument your application. So should something go wrong, you can see what go wrong with a lot of additional informations. Like we had some breadcrumbs that led up to, for example, exception. We can also ingest your log messages that you maybe produce with Microsoft.extensions.logging. What we're currently working on that is now shipped across our SDKs, which are the components that you include in your app to instrument your applications, is metrics. So soon we'll be also to get a hold of metrics in .NET and show them in Sentry.
Yeah, wonderful. Well, surprise, like if you write code, things break. We just need, faster, quicker ways to fix things with all the observability. Now, when a crash happens with something in my code, we don't have a lot of time because there's limited number of things meaningfully you can do on a process until it, completely is gone. You want to capture as much things as you want. So I know you have been working on something very cool, a desktop crash reporter. So why don't I bring up your desktop and you walk me through it?
You mentioned it in particular with native crashes. Process is gone. With a managed exception, there is still hooks. You can link and execute some code and get all the information. But with native crashes, the process is gone. So that's a bit of a tough luck. So we need something quick to fire up. So we built as a bit of more than just a demo. You can use this very much in production. The Sentry desktop crash reporter, which is just capturing that native crash, spawning it in a process, and you have some time to review that crash and also send some additional information that will be then sent to Sentry. So your user, for example, of your application, maybe a game, can then enter additional information that led up to that crash, and you then see all of this in a Sentry.
I love it because like you're capturing as much information, getting user consent and screenshots and whatever else that devs need to go fix this. So now this app needs to be running on multiple platforms, right? You need Windows, macOS, Linux. So what were your needs? And I am guessing this is written within a platform.
Most definitely. The cross-platform, the true cross-platform aspect without needing to write too much native platform code was the primary choice. The secondary choice why we chose Uno is that it also allows self-contained single file deployment so that you can just take this crash reporter, ship it easily alongside your maybe .NET application, maybe a native game or any other application for the user then to have a full nice experience without any hassle of too much setup.
Yeah, and I'm guessing like performance of the app is really important because when something bad happens, you need to quickly spawn off a different process and spin up this app.
Exactly. And we will then see in a demo how quickly the Uno platform then spawns up. It will just be there. You don't even notice that your process has gone. It's not just Uno appearing.
Yeah. Well, enough talk. Let's see it.
Yes. So let's jump into our application. So this is a very simple .NET application. We are using .NET 10, and we also publish for Native AOT, which is
Nice.
now not only enabling the .NET SDK of Sentry, but also our native SDK that comes along with the .NET SDK. So we then need to do a little bit of setup. We need to tell where should this crash reports be sent to. We could also enable logs. I know that Uno Platform supports Microsoft.extensions.logging. So we also have an integration. You could set your logs to Sentry by that. And the most important point, we now point Sentry to this self-contained symbol file Uno-based crash reporter application. So should a native crash happen, this will fire up immediately. Now let's set some additional information, some ambient information. We can set tags, which later on we can filter by. Then let's call into a function. We will set a breadcrumb. This breadcrumb will then show to what happened leading up to the eventual crash. Let's call another function. Let's add another breadcrumb. And let's call a third function. This is the bad function. A last breadcrumb is added, and then we cause a native crash. So this is a crash that we can't really observe out of the .NET process, and the process will be gone immediately. And when we run these applications, we see this has been Native AOT deployed, and it self-contains. It's just a single application. And when we run this, it just goes boom immediately on my second screen.
Wow, that's quick.
Sentry crash reporter just spawned up, and we get all of the information that was related to this crash. We get, well, this is indeed an access violation or some segmentation fault. We did something bad with pointers. We can take a peek on the tag that we previously added, some information of this trace that was captured, information about the SDK itself, and we can take a preview at the envelope that will be then sent to Sentry. We can add some additional information what led up to this crash. Well, in this case, let's say hello Uno. And as a name, well, it's Sam and Stefan who have caused this error. Let's submit this crash to Sentry, and let's switch to the Sentry platform. So we now look at Sentry. I have real-time update enabled, so the crash, I'm taking my hands off the keyboard. Now the crash will appear in just 10, 15 seconds. So this message, this envelope has been sent to Sentry. It will be now, we call it ingested, so it will be prepared. We understand that an error has happened. Now you could also have custom alerts that send you a Slack message or an email or something else notifying you that a specific crash with some parameters has happened. And well, if the demo goats are good with us, and here they are, so we now got this crash now here reported. And we can see again a lot of the information that we saw in the crash reporter based on Uno. We know which operating system this happened on. We saw that this is a fatal unhandled exception. The message that we added just now, and all of it, we symbolicated our application so we can utilize the information of the stack trace. Well, this is a native stack trace. We see a little bit how what .NET is doing under the hood leading up to our native crash up here. We can take a look at the breadcrumbs. We see those 3 breadcrumbs that we emitted, that led up to that crash, and also the tag that we set, additional contexts, SDK information, and we see there are images, symbolication is available. So we can now utilize this information and ask SIA, our AI component, to give a bit of a root cause analysis. Why did this crash happen? I already executed this ahead of time, so it's a little bit faster. And SEO is looking at our code and our call stacks and seeing what happened. So we initialize the SDK, we set a tag, we're calling up a bunch of functions and adding breadcrumbs, and eventually we invoke cause crash, which is causing the crash, and calling this method, which is then invoking a native method in the Microsoft Visual C++ runtime to get the length of a string, but we pass a null pointer. So this is causing the segmentation fault or the access violation. And
error.
Excuse me?
It's like a classic error.
Oh yeah. And yeah, although this was a native crash and our process that caused this crash was gone immediately, we had our crash reporter and Uno platform kicking in and displaying the error for us, and we can add some additional information before we just send it to Sentry.
This is beautiful. This is so much, information right up front. So, you have full visibility as a developer as to what exactly happened. Because without this, like, it's a native crash. You will not have any stack trace. Like, you won't see anything about it. So this is awesome.
And maybe the best part about it, I just before we got live here, I also essentially the same code base, just build it on my macOS as well and run it, and we get the very same crash reporter, and it looks the same as on my Windows machine. So this is
beautiful.
the amazing part I like about Uno.
Yeah, that's the whole point. Like a single .NET code base, cross-platform app goes everywhere. iOS, Android, Mac, Windows, Linux, you name it, and single unified rendering, really quick performance. That's what we are all about. And you are doing things here with AI, trying to look through the logs and discovering what happened. We are doing AI to help developers, write apps faster, with human in the loop. So I think like development tooling and error reporting tooling, we have all the ammunition to build up some amazing stuff now. There is no excuse. So this is really awesome, Stefan. Yeah, thank you so much.
There really isn't the development experience building our crash reporter was almost too easy.
Yeah. Well said. All right, I'm going to bring down your desktop here. But Stefan, thank you so much for joining us here. This is an amazing showcase of what's possible with Uno Platform, and congratulations on the desktop crash reporter. If Sentry can pull off things like this, we really don't have an excuse to write really awesome, native apps. So, Stefan, thank you so much, and best of luck for what lies ahead.
Thank you very much for having me, and thank you very much for Uno. It's amazing.
Thank you.